Welcome in our session. Good afternoon. My name is Martin Piala. This is Marko Manev. We are from SUSE IT, Platform Engineering Organization, and we will tell you how we built our internal developer platform. Why are we here? I think we built pretty cool thing, combining multiple SUSE products, and we want to share it with you so you can benefit from it as well. During our session, we will tell you which challenges we faced, how we failed, and how we got back on the right track, and how our lessons learned can help you to build the internal developer platforms in your companies as well, and how SUSE products can help you with that. This is for us first time we are presenting this externally, so please bear with us. At the end, there will be time for your questions, and maybe during the session we will ask some questions towards you. So, what is internal developer platform in reality? It's a PaaS, platform as a service. It's components put together which serves as a self-service. It's a layer between infrastructure on the bottom and the applications running on top of them. It's a set of tools which developers and engineers are using for developing and running their applications. For example, version control system, pipelines, build system, artifact registry, execution environment, observability. And that is something which we want to build for our developers in company, that they would have unified experience, all of them could use the same platform. Well, and originally, we thought that we already had a platform. In reality, we had Kubernetes cluster running somewhere in the cloud for some specific reasons. We had some pipelines, and we had monitoring. But we have some issues in some areas with this platform. First of all, we didn't have proper development environment. I mean, we had production environment, and we have development environment, but they were not connected through pipeline, they diverged in features. So technically at the end, we had playground and production environment. And that's something which caused some outages when we were doing changes or we were doing some upgrades. Second, we didn't have proper responsibility split. We were involved in the application deployments, even when there was an incident. Our team was the first point of contact for these incidents, even if that outage was purely on the application side. So this didn't work well. We didn't have more than 10 customers. This is not a problem per se, but we missed the point. We had a cluster which was providing services for some of our customers, but we didn't know what the other customers needed. And we didn't have self-service. Since we had only a few customers, we were able to provide them services on an individual basis, and yeah, that was it. Any ideas here why this setup was not right? What was wrong with it? So firstly, reliability, availability. If you don't have a reliable platform, people are not going to use it. Responsibility split. We were involved more in the roadmaps of the applications running on the cluster than on the roadmap of the cluster itself. We didn't know properly our customer base, and when we were working individually, it was not scalable at the end of the day. If you would have more customers, we wouldn't cover their needs. So we had a platform which didn't work for all our customers. Well, so we set up to build, we wanted to fix the scalability or the reliability part, and to have a development environment which would mirror the production environment, and have some improved pipelines and rework the code. It looked like a simple undertaking. So this is what we wanted, and this is what we ended up doing. So over some time, with working with other different teams, the project scope kept growing. We wanted to redesign the network. We wanted to add different features. We spent a lot of time designing the low-level details of Kubernetes components, which network components we will use, airbag policies, changes on the IAM side. Well, we were designing a lot of things, and we didn't focus on the important one, to focus on the customer problems or the business problems. So we were not delivering value. After a few more months, we thought that we are close to the finish line, but in reality, we were not making any progress. So it was, at the end, quite hard for us to throw away 6 months of work, and yeah, it was quite demotivating. So, Marco, how we will move from this?
So we needed to take a step back, and we needed to do something different, apparently. We needed some leverage, something that can help us whenever we want to redesign certain part of the infrastructure, something that can influence other teams and organizations within the company, that what we want to do is the right thing. But we didn't have that. So we looked into a process that's used by a lot of successful companies, which is the working backwards process. And this thing helped us to flesh out ideas and to define what our problems are, like the customer's problems, without actually spending any time building software, writing code, or deploying an infrastructure. So what does this mean? This means that if you want to do something new, a new project, a new product, you just start with the customer, work backwards from there. And in reality, you write a press release for an imaginary product. You pretend like you're like a couple of months in the future. Your customers are already using your product, and you just write from their perspective. Describe what the product is. You have a couple of questions there that help you really get close to the customer experience. Why they want the product, why they need it, what it solves for them. In reality, how we used it, we had to put aside everything we had, because it was important for us not to have our existing environment, existing problems and everything, to influence the problem definition. So we wanted to really understand what our customers needed, what the internal developer teams needed, and after that, we would focus on providing a solution. We wrote our PR FAQ. We took it to the developer teams. We had sessions. We discussed with them. We took their problems, desires, whatever they wanted, whatever problems they were facing. And we organized them into user stories. We then grouped these user stories into features. And this is what our requirement document looked like. There's just like a sneak peek into some of the user stories there. And we did not spend any time for this to actually do a proof of concept or to even think about what products we would use to solve any of those requirements. We just focused on them. And the last thing we did here is we found a name for our new product, the one we described in the PR FAQ. We called it OpenPlatform. And from then on, every document we created, every design we wrote, we used that name. And later on, like within a week or two, we started reading that name into our internal chat groups. So people were already talking about the product, and we haven't even designed it yet. And that kind of motivated us to push forward. And we learned a lot, but what we actually learned from our customers, I will leave to Martin to walk you through.
So SUSE has been around for more than 30 years. And there is a lot of diversity in the applications we have. There were teams which were looking only for where to host my container, where I can run my container. But there were also teams which were looking for, or which have applications running on the virtual machines. And they didn't plan to containerize them. our open platform should provide for both. So if there wouldn't be any specific requirement, we could move the workloads to the cloud. But some teams, they had very specific requirements, mostly because of the certification SUSE as a company holds. For example, we need to have full control of our software supply chain for our products which we are creating. Infrastructure needs to be owned by SUSE and maintained by SUSE personnel only. In some cases, there are requirements for some geographical location, so the data and infrastructure is residing in EU or US. And these are not feature requests. These are hard requirements. We couldn't build multiple different platforms. They would diverge soon in the functions, in the features, and it would be hard to maintain all of them afterwards. So we had to create a solution which would solve all these defined requirements. And let's see how we did it. So now, we had collected the requirements. We drafted the target solution. And we proceeded to deliver again. Let's see which decisions we had to take and what worked for us this time. Originally, in the previous project, we were comparing a lot of different tools, products on the market which would fit for our tools, for our platform. This time, we agreed that we will use SUSE products first, wherever possible, and only if there would be a missing feature or we would found a bug, we would provide the feedback to the engineering teams. Therefore, we were not only eating our dog food, but we act also as a customer zero, so we provide feedback to the engineering teams that helps improve the SUSE products not only for us, but also for you as a SUSE customers. We focused only on the defined scope. We concentrated on features which are adding value, and we were working only with the tools which were available. We were not introducing any new additions. No changes in the network setup, no changes on the IAM side. So only what was available. And originally, we were planning or spending a lot of time to have the perfect platform, to get something which we would do the perfect decisions. But it was very inefficient. Now, we prioritize to create minimal viable product, and that allowed us to provide functional, ready-to-use platform for our customers quite quickly. Once we had the MVP done, we focused on operational excellence, and during the time, we were gradually adding some additional features. So Marko, will you tell us how we build the MVP?
Yeah. So for the MVP, we first took a look at what products SUSE offered, and we focused on only the core requirements for our developers, which means they needed an environment where they can run their applications. They needed to make sure the applications are actually doing what they're supposed to do, so that covers observability and logging. And that was pretty much it. So for compute, we decided to use Harvester for the virtual machines for the on-premise offering. We used RKE2 for the container offering, and we used that for both our on-premises environments and the cloud environments as well. For storage, we used Longhorn. It's pretty well integrated with Harvester and RKE2. In AWS, in our cloud environment, we used EBS. For observability, we used Prometheus, Grafana, and Alert Manager, which are basically open source standards for that problem domain. But they are all pretty well packed into the Rancher monitoring chart. And this basically deploys all of these three products in like a single click, and they're all integrated together, and you just start using them right away. logging operator is the same thing, is quite similar to the observability offering. And that defined our logging pipeline for both Harvester and RKE2. And for the operating system of our nodes, of course, we used /15. And we did not spend a lot of time, as Martin said, to dive into every single setting and every single possibility that all these products offer, because there are quite a lot of products, and our team is not that big, and we don't have a lot of time to do all of that. So we decided to trust the default values that are offered by these products, and we were going to diverge from the defaults only when we needed to. So this cut down a lot of time in our development. Next thing, we built only what we were missing. So we didn't have a nice execution environment, so we built that. We did not start installing straight away or like setting up the environment. So we wrote a couple of design documents, high-level design documents, where we outlined what we want to achieve, and we paid really close attention to what problems we wanted to solve. Because we wanted to solve our customers' problems, and we did not want to be influenced by the products so that we can tune the problems so we can use these products. So that was pretty important for us. To the left is our cloud environment. This is just like an example of what we have. It's pretty simple still. We try to keep everything as simple as possible. We have a Rancher cluster running, like we have Rancher running on an RKE2 cluster, and our downstream clusters are running on EC2 instances. On premises, we have the same Rancher management cluster, but we also have a Harvester cluster, and the RKE2 cluster is hosted on Harvester VMs, and we also offer VMs to our customers. So basically, the offering to the customers is a Rancher project. And in the RKE2 cluster, they use the project to run containers. In the Harvester cluster, they use the project to run VMs. This was the MVP. So this is what we started to deliver. But if you remember, we had multiple requirements that we had to fulfill. So we had to run on premises, we had to run in the cloud, and our cloud and on-premises environments, they are not allowed to have any network communication between them. So we had to have multiple Rancher installations, and we had to manage them as well. But luckily, Rancher integrates with an identity provider, supports multiple identity providers. We use that. We also use the Rancher Terraform provider, and we wrote a pipeline, a couple of pipelines that are managing our installation. This is what our MVP looked like. Each square here is like the pictures from the previous slide. It was getting too complicated to put all of them in the one slide here. So when we launched, after 3 to 4 months of development, and we spent those months to develop the automation around this. So we spent 4 months to build like the Terraform code for the environments, to build the pipelines, to make sure everything is deployed together, integrated, and all of those things. We launched with 3 production environments: cloud, on-premises in the US, and on-premises in the EU. And we also had development environments mirroring each of those productions. So this fixed our first problem, which was the reliability part. With this setup, we were able to provide a reliable platform for our customers, which means that any change we make is tested before it goes to production, so we are not pushing anything straight to production. We achieved this by having all of the code definition of the whole infrastructure in one place, and then we use that and we copy it with the pipeline. So we don't have separate code base that defines one environment and separate code base that defines another environment. It's just one, and then we just copy it with the pipeline and we deploy it everywhere. The other two environments, we added them later. This is the DMZ environment, which allows us to host publicly available services. And the difference between this one and the others is that we just expanded the pipeline for two more environments, and that was it. That was the work we had to do. It's also protected by extra network firewalls, so that's why it came a bit later. It took us not more than 4 months for the whole thing. And our team was 2 or 3 engineers back then, and this was not our only project that we were working for. We also run other applications for the developer teams, and one of our biggest product that we own and we look after, I'm sure you're familiar, is Bugzilla. So this was kind of like a side project to see if it works, and if our customers like it, then we would invest more time in it. We have a couple of examples, so just a simple thing, I'm not sure if it's readable. The top picture is our pipeline that deploys our downstream clusters. And just an example, so we have our Terraform validation, our tests, we build the artifacts, and then we deploy through one environment, test everything, make sure it's running well. The testing part is still manual, so we still haven't automated that, but it's planned to, of course. And then we continue pushing the changes down the pipeline to the other developer and production environments. The bottom picture is extract from our pipeline of how we onboard customers. We built it semi-manually, so it's not fully automated onboarding experience. And the only manual thing is where we, as the platform team, we need to define a configuration file that is read by our Terraform code, and then everything is still deployed automatically to production. So the end result is every single change that we make into our environments, it goes through our pipelines. We are not logging into the UI, or we are not running any manual commands against production. And that helps, of course, with reliability. Here we have like an example of the customer definition file. On the top, we have the identity groups. That's how we define the permissions for the projects. We have the limits, of course, and then we have like in what rancher environment, what downstream cluster they need to be deployed into, and that's basically it. You can see we have multiple clusters here defined. So this cluster here is basically like the project from this slide. This picture is defined in this cluster here. The top one is the Archie2 project. Bottom line, the bottom one is the Harvester project. So same interface, same file where we manage everything. This one is an example of our customers. So we have one file per customer, and the groups that we saw on the previous slide, they're defined here, and they are pushed to Rancher through our pipeline, and they are linked to the defined roles. So this is basically where we spend those 4 months in building all of this automation around it. Of course, this was only the MVP, like the basic thing that we needed to deliver so that our customers can start benefiting from it. We have plans for evolution, and we're already working on that. So, Martin, can you walk us through with the next steps?
Thanks, Marco. Just maybe to add one thing here. As you see, there is a group, And when people are being added to the group, they immediately are getting access to their Rancher projects, which were defined in previous site. So it's quite straightforward for us to onboard new people for a project. Once we have done the MVP, we focused, and you can see on the left side, on the operational excellence. When you have customers using your product, you want to ensure it's stable. And to make sure it's stable, you need to have some tools around. You need to have monitoring, which follows with mandatory dashboarding. You can have alerting in place that you are notified where there is some degradation or there is an outage. And you can have logging. So you see the logs, what is happening in different components, or what happened. So you have monitoring, dashboards, logs, alerts. These all are useless if you are not processing them. And that's in parallel, we established operational review sessions. We've been doing these sessions since the beginning of the project. And in these sessions, we are analyzing the recent events, incidents. We are creating root cause analysis. We are defining correction of errors. These are the actions which prevent you to have the same incident happen again. And all that goes hand to hand with observability. So in these sessions, you are defining which logs you need to analyze, which metrics you are missing, which dashboards you want to see. But on the other hand, it helps you to define where I want to add rollback in our pipeline. Or do I have covered escalation paths for different products we are using? Or, yeah, some others. I just missed something. You need to take into account that there will be always incident. Things will always fail. An operational review will help you to make the incidents shorter, fewer, and smaller. It helps you also to populate your roadmap, so which features you want to add for your operational excellence. Well, and the innovation. What we started with the MVP, as Marco said, we had some production environments, and we fulfilled the hard requirements which were mentioned. So now we had environments for containers and VMs, both in cloud and on-premises, and we have environments in US and EU. When more customers started using our platform, they reported us some obstacles which were preventing them to use the platform more. So we later added the DMZ environment for publicly faced services and support for IPv6. We conducted also survey, which populated our backlog quite heavily. And if we have any product owners here, you know that we need to refine the backlog and prioritize the items there according to the value. So it's some other repetitive action we are doing. Since the beginning of the project, there is one more activity we've been doing regularly. Every second Friday, we send out a newsletter. What's new with OpenPlatform? Sometimes the sprint increment is smaller, sometimes bigger. But for the whole product lifecycle, we are trying to keep our customers informed and engaged. So, okay. Now we have reliability, we have operational excellence. At the beginning, there were 4 areas which didn't work for the previous product. Do you remember which one we didn't yet touch? We did not speak about them yet. Self-service. Exactly, self-service. And there was the not proper responsibility split. So we were involved in the applications, deployments, and supporting them. So we had to do one organizational change. That's platform engineering. And this is a definition I found on the internet. You can look on the shiny, nice buzzwords. Cloud native, self-service, internal developer platform. Operational necessities of the entire life cycle of an application. Yeah, that's a great one. So, what we were doing before, was not really scalable. We were doing DevOps approach. With each new customer, we had to repeat the same manual steps. We helped them creating repositories, setting up the pipelines, creating the namespace on the cluster, helping configuring load balancers, and so. And this couldn't scale. We wanted a solution which could scale regardless of the size of our team and the size of our customers. So, what we wanted to do is create a platform or a product which can be consumed as a self-service. And once we had it, like with our open platform, what we achieved is that we empowered our customers so they are able to maintain their own environment more efficiently. And on the other hand, it removed or it freed us from the repetitive operational actions which we were doing, and we could focus more on the features or items which were adding more value. So now we had some scalability for our customers, and we were not the bottleneck anymore. We are getting to the end of the presentation, so let us summarize the benefits of our internal developer platform. Marko, will you tell us?
Of course. So we ended up with offering a unified developer experience. What does this mean? So we have customers, developers that need to deploy their applications on premises. We have customers that need to deploy them in the cloud. And we also want to help some customers move from on-premises to the cloud, or if they need, in the other direction. And with Rancher, we offer them same environment, same interface that they can use on-premises and in the cloud. And when they need to migrate, it's on them. They make the decision when they're ready for the migration, and they don't have any learning curve if they want to use something different from on-premise or cloud. We also have unified operations, which means that our team can manage both like on-premises and cloud environments with the same processes, same tools, same skill set. We don't need two different teams to manage these two different environments. We also integrated with a lot of existing things. So we didn't build, if you remember, we only built like the execution environment. We didn't touch on the build environment. So we use the open build service that's already existing in the company. We use the same version control system that everyone else uses. We use the same identity provider and lots of other things. So we only built what we needed, and everything else we just reused. And that's the beauty of the platform, because it's easily integrated with an existing solution. The other thing that we achieved is the innovation part. So previously, when a developer had some work to do, had some idea they wanted to test, they had to open a ticket with IT. IT had to process the ticket 2 to 5 business days, usually, sometimes more. They build the VM, they provide the access to the developer, and maybe after a week or two, the developer finally has their hands on the machine and they can start work. With this, they get their own space, they get their own project, and whenever they need, they just a couple of clicks and they have the VM, and they can do immediate testing, and they can do their work much better. Scalability part, what Martin just mentioned, is applies also to the hardware and the infrastructure, because we are now consolidating multiple workloads from various parts of the company within one platform. It's easier to manage, but we also fix the people scalability part, where it's not that easy to scale teams out. And the maintenance overhead. Previously, we had lots of developer teams to buy their own hardware, install it, install the OS, build Kubernetes clusters, manage them, and then come and deploy their applications. With our platform, they just come to us, we onboard them, and after that, they can run whenever they need to. in short, what did we learn? We learned that you must understand what your problem domain is. And the tricky part here is that you need to understand what your customers need and not what they want. It's not always the same thing. The other obvious thing is fail fast, like don't spend months trying to build something that you don't really know why you're building it or how it's going to look like. Next, you can never avoid complexity as much as you try. The main driver is like try to simplify things, but if you end up getting into a complex solution, just automate away the complexity and you can continue. Next thing is things always fail, so you need to be prepared. And you do that through operational excellence. The responsibility split is also important because your customers need to know what you are responsible for as the platform operator, but they also need to know what you are not responsible for so that they know their responsibilities. And the best thing we learned, can you tell us?
Yeah, so with our internal developer platform, you are free to choose what works for you. If you need environment in cloud, choose that one. If you need environment on premise, yeah, you can use it. If you need both, just use both and combine them. So Rancher gives you the opportunity, gives you the solution with unified experience, regardless of where the infrastructure is deployed, whether it's on-premise or in cloud or in US or EU. And yeah, that's it. So this is how we built our internal developer platform. And you can build the same in your companies. And use what works for you. Choose whatever products you want. Or choose SUSE products as we did.